So I'm very excited to speak with you today, particularly after the last panel, because I think the last panel had a lot of practical advice for how we need to better operationalize the opportunity that we have with generative AI. And I want to talk about how we operationalize the leveraging of data science to transform our business, transform entire industries, and thinking through the proper architecture for an enterprise in order to architect for success. But before we dive into that, I wanted to first tell you a little bit about myself. So I'm Kevin Cochrane. I'm Chief Marketing Officer here at Vultr. If I haven't met you, would love to connect with you one-on-one. And I'm a resident here in Miami. I come to Miami by way of San Francisco, where I lived for 45 years and went through the first two significant waves of compute infrastructure for the modern enterprise. I'm here in Miami specifically because we have something very special and dramatic happening here. We are now at the dawn of the third age of compute infrastructure. And with generative AI, we have an opportunity to accelerate our ecosystem and build a whole new class of unicorns that could literally transform the way we live, work, and play. Now, to talk about these successive wave compute infrastructure, we have to go all the way back. With the dawn of the internet and the availability of the first web application servers, we saw enterprises move en masse to the web. Now, obviously, the web began many years before. 1994, you had the Apache's web server, first, Mosaic browser come out. April 1996, Apache web server comes out. I start my first company and patent a system and method in development for websites, okay? Which was a process for how enterprises could actually scale the development of websites and web applications, CGI based at the time, to all endpoints around the planet. Now, that obviously became industrialized because we had the significant infrastructure that became available with the first web application servers, kind of the generative AI moment, the open AI moment, the ChatGPT moment of the web. And suddenly you had organizations like GE say the web is priority number one, number two, number three, and everyone started to rush to build new web applications. Now, one of the things that we learned during that process is in order to accelerate, in order to really unlock the benefit, it took time for people to understand how do they operationalize the ability to scale to multiple developers, multiple development teams, multiple business units, and to be able to deliver applications and application updates continuously to all corners of the enterprise and all corners of the globe to reach their consumers. We had to learn how to do continuous innovation. We had to learn how to do continuous development in the web application space. So 10 years later, we saw another epoch of compute infrastructure. I moved to Europe, got involved in the open source industry. We started popularizing the notion of developers taking advantage of cheap compute infrastructure on Amazon. This was the wild, wild west of the dawn of the age of cloud compute. And again, cloud compute started out as skunkwork projects, an individual developer hacking things together on low-cost EC2 instances, just like in the early days of the web. Someone sitting in a closet, hacking things together, testing out a new application server, throwing something up and seeing if it's stuck, okay? And then in the cloud space, we had to learn all new processes, all new policies in order to scale the adoption of cloud in the enterprise, to secure it and to ensure good return on investment of all of our efforts. So roll the clock forward again, and we're actually in the most significant phase of the evolution of compute infrastructure. And this isn't just architecting for the cloud, this is architecting on cloud GPUs to basically have a new generation of applications that are AI powered, okay? So the past 20 years of compute infrastructure has all been based on a singular notion that we were riding up Moore's law on Intel processors and CPU architectures. And we have hit the limit in terms of how we can shrink microprocessors and pack more on a disk and get more firepower out of our CPUs. What's happened in 2020 is the incredible roadmap that NVIDIA, we are partners so I can plug them, has put in place for GPUs to truly take Moore's Law to the next level. This is the rapid innovation that you're seeing coming out with the A100s, the H100s, GH200s, the compute architecture that fundamentally made ChatGPT possible in the first place. Without this innovation in GPU architectures, you wouldn't see the generative AI boom that we're seeing today. If the past 10 years was the build out of compute infrastructure for the cloud, and we all know that Amazon, GCP, etc., the next 10 years will be the rebuild of compute infrastructure centered first and foremost around GPUs, so that every application that has been built over the past 20 years for the web and for mobile devices will be rebuilt to be based around generative AI. That is a fact, or I guess it's an opinion. But I think we actually saw that as well from the PagerDuty folks. They were very clear. Every aspect of every one of their products is going to have AI at the core. This means we have to rethink how we build and deploy everything in the cloud and how we put GPU architectures and the scaling of GPU architectures at the core. Now, I don't need to tell you, GPUs are a whole different world, okay? Whole different world for me. The GPUs are always the secondary processor in back of everything. Back when my early days of product management of my first company, I was always worried about the next iteration of the next Intel chip, right? That's everything I was focused on. This is a whole new world that changes the game on how we build and deploy everything we've ever done before. And I don't need to tell you that there's significant bottlenecks on the GPU side that we've never had to deal with before on the traditional cloud compute CPU architecture side. First and foremost, getting access to GPUs and provisioning them in your data center and getting them configured so that different teams can access them to run all of their training workloads takes a hell of a long time. So you're looking at a process that can take anywhere from 9 to 12 months to get basic GPUs procured, provisioned, configured, and made available to your different teams for build, test, and deploy if you're putting them in your traditional data center. This is not like the CPU world where in your data center operations are so efficient, you could just spin up and rack whatever you want as quickly as you need it. This is a different world. These are much more expensive systems. They're much more complex systems. There's supply chain delays. You have to have much more planning up front, and you have to have specialist resources to make sure that these things are operationally acceptable to meet your dev team's parameters. So this is a scalability bottleneck if you're an enterprise and you want to do anything more than you're doing today, which is a skunkworks project. In order to architect for success and to architect for growth, you need to cut this all out instantly. And this is the new architecture for the cloud, which is on-demand provisioning of any GPU anywhere you need it in the world so that all of the traditional delays of procuring and provisioning and standing these things up in the data center don't apply. Now, this is all well and good. I think everyone here is probably already bought off into the notion that everything they're going to do with respect to AI ML is going to be done in the cloud. This is a pretty advanced crew. But for a lot of traditional enterprises, they don't actually embrace the notion just yet that GPU architectures are a significantly different beast. And even where they may have lagged in core cloud compute, moving workloads to the cloud, in GPUs, that is really a non-starter because they'll actually never get started. But the part that's not spoken out loud is that even if you start with on-demand GPUs in the cloud, GPUs, again, are a totally different architectural beast. Setting up and configuring the GPU so that actually ML engineers can be ML engineers is really tough. all of the different drivers, the CUDA support, you name it, all of this is super complex. So there's a gentleman that I work with in India, actually. His name is Janakiran, and he's a leading data scientist, extremely well-known in the Bangalore area, and India more broadly. And I was talking to him about our latest innovation that we're taking to market just next week on Tuesday, and he was so excited about it, okay? Because what he said was, every single time he has to do a new project, he has to find and get access to a GPU, and even from the hyperscalers, it can be impossible to do it these days. But he said, moreover, he said his problem is, it's a 12-hour project for him to actually build. Once he actually hops into his notebook, it can take him up for 2 weeks, 2 weeks, just to get the CPU configured so he can work against it. So this part that's not spoken out loud is, as we're having newer and more successive waves of GPUs come out, the A100, 12 months ago, the H100, 6 months ago, now it's the GH200 next month, coming soon to Vultr, by the way, available on demand in October, first one to bring it to market. All of these new GPUs, it's more and more complexity. If you're an ML engineer, you just want to actually do your job. You don't want to be a systems administrator. This is a bottleneck for success in the enterprise. This is a bottleneck to growth. If you want to scale your data science team, let them be data scientists. So the part that's not spoken out loud is you need to have not only on-demand GPUs, you need to have on-demand GPUs that are fully configured and ready to go so an ML engineer can go in and just get their job done. We talk about personas, we talk about jobs to be done. I will tell you, in my persona that I have for an ML engineer, nowhere does it say that they're a systems administrator. Does anyone believe an ML engineer should be a systems administrator? I don't. I think an ML engineer has specific jobs to be done, and that is being an ML engineer. That should be able to spin up anything they need in the cloud in less than 20 seconds, and they should start being productive, pushing code that very day. So this is all, I'm very passionate about this point. So this is all well and good. And this is going to help you actually get individuals to start being able to work at scale and quickly. But we need to think a little bit more broadly, because we do know that beyond the initial private projects, beyond the skunk works that we're currently doing today, we're trying to actually build a global architecture to build and scale all of our web applications that are now going to be powered by AI. Again, I look at the PagerDuty example that we saw this morning. These are SaaS applications available to a global customer base that now have AI built in at the core. So what this means is we need to think back to all of the operational processes that we put in place for core web applications, and then again for web applications, cloud native applications we were building, and we need to immediately apply it to GPU architectures and our AI models. Because if we don't, we'll never actually have secure, safe, continuous innovation and delivery. And this is complex if we don't think about this up front. So what that means is what everyone's been talking about in all of the media is, how do we actually get access to a whole bunch of H100s to basically build and train our foundational model, okay? That's just, you're just training the foundational model. That's just one set of GPUs inside either your own data center or just available to some sort of centralized team. You haven't changed any of your applications. You actually haven't changed any of the value that delivered to the customer. You have like a prototype. You actually have to take that foundational model that you train on, and you actually have to make it available in different regions and potentially fine-tune it on locally available data sets. If you're a healthcare company, you cannot fine-tune your model for predictive healthcare outcomes on any sort of German population set. You can only fine-tune that on that German population set with data in Germany, with GPUs in Germany. That data cannot leave the country borders. So you can build your foundational model, but the training oftentimes has to use locally available data sets in different countries. Moreover, once it's fine-tuned, when you're running inference, no one is talking about the edge. In the cloud native world, everyone is focused on pushing everything to the edge. So there can be the lowest possible latency. Get compute as close to the 5G towers as you possibly can. Why are we not talking about this with AI? How are you going to deploy from a training environment to a tuning environment? And then how could you push AI as close to the edge as possible where your application code is running? If your mobile application code is running next to a 5G tower in Dubai, well, you're going to want your inference to be running as close to that as possible, because otherwise you'll have too much latency and it will just suck. So let's not make sure it sucks. So what we believe is that there is a new application architecture that's needed for AI ML, which not surprisingly is modeled after a traditional, CI/CD pipeline. And what we believe that the core of it is to make sure that you have available a registry that is both public and private, that synchronizes across all data centers around the globe, where a public registry can be an exact mirror that contains every single open source foundational model that you may want to start with, as well as all of your core models from our partner, NVIDIA. No matter where you are, if you're in Osaka, you should be able to have a local mirror of every foundational model in Osaka. These things are big. Let's not have a lot of bandwidth consumed. It should be locally available. Just get started. Moreover, once you do your training for whatever training cluster you set up in Osaka, well then, once you actually finish, building that, you should be able to share it via a private registry with every other one of your dev teams all around the world. It should be instantly synchronized and locally available and accessible to everybody, safely and securely, because it's private, of course. Then, if you want to go into that private registry and then pull it into a region to tune against a regional data set, you should be able to tune it, push it back to the private registry, and then make that privately tuned model available to all edge locations. So we have to think about the entire pipeline about how you take all of the data, all of the code, and push it through different successive clusters of GPUs in a safe and secure manner, and push it as close to the edge as possible where it could be co-resident with your actual cloud native application code. We do believe that this is the next 10-year cycle as people instrument and build out application architectures that fit this model. The good news as well is using a container registry, it's based on Harbor by the way, so pretty safe, is you can also instrument all of your internal checks for security and compliance, so you make sure that you can make sure that everything that is in the public registry or in your private registry is 100% adherent to whatever SecOps policies that you may have. So a little bit about Vultr. So obviously we're very passionate about this next 10 years and changing the global cloud compute fabric to put GPUs at the core and to get people to start thinking about architecting appropriately from day one. I've lived through this a couple of times, so I know what happens if we don't get it right in the beginning. It's a lot of pain, it's a lot of hurt, and I think we all just want to move fast, do things right, and change the world. So Vultr, we're privately held. We're based here in South Florida. About 150 million in revenue. We have the scale of Amazon, same number of regions, 32 regions, 6 continents. We've never talked to anyone before because we just started doing selling and marketing. We were 100% product-led growth. But now that we have the advent of GPUs, we're investing heavily in sales and marketing and trying to meet people and help them on their mission because we're here to change the world and we want to help you do the exact same. So with that, I'd like to say thank you very much and I'm honored to speak with you today. Take care.